So I want to check squareness of my fixture. So I put one of these 3/8 indicator. It's just a normal indicator, except at the top, instead of having you be able to pull the indicator up and down, it's internal to a 3/8 inch thing, so you can mount it in a collet, which I did. And it looks like side to side I have a little over 1/1000th of an inch of squareness, which isn't terribly bad over 14 inches. So we're gonna call this good. It's about 1/1000th. That's actually much better than I thought. So this is the only indicator I've got like this, but this is a 3/8 inch shaft that's built as part of the case here. And so I could grab that in a 3/8 inch collet under here. And then I just put an extension on the end so I could reach down in the groove. All right, so here's my new vise jaws. And so instead of holding it vertically in the vise like this with normal vise jaws and then not being supported for the much longer pieces, I made custom vise jaws, which you just saw. They hold the part at a 10-degree angle. This one here, the shelf is lower than the other side, so it's basically just pushing a 10-degree flat up against it. So the thing should seat nicely. And I can tap them down. Here, how solid that is. That's beautiful. And we can just come across here now straight, and I can make as many of these as I need since this is a replaceable part. So I thought it was worth a little bit extra effort in order to have a more versatile solution. So that's what I went for. On a second pass, I'll dial it in, get my 0, and then I'll just do all the pieces on one side. Went down 7.5 thousandths, or 10 thousandths rather. I went down 10 thousandths, and that's cleaning it up, I believe, all the way. I can't see it coming out the end here. It looks like. So there's my 10-degree angle. I think that turned out really nice. Good finish on it. And I'll go compare that to the original. Okay, I flipped the part over. I have the beveled side down in the corner, which will still take off, which will create the exact same bevel over here. Remove more on this side than this side. And I've gone up 10 thousandths so I can try and dial it in because I'm looking for a specific width here. That's why I pushed the part over the edge. I don't know if you noticed, but we're not cleaning up all the way across, which is what I wanted, because I wanted to walk it in. And I wanted to be able to measure this width. I'm shooting for something in the middle. The other one's tapered. The original master is tapered. I don't think that's on purpose, so I'm shooting for something in the middle of its width. Should be just cleaning up this little flat spot that was left there. I went down another 10 thousandths. And it is not completely interesting. All right, so next stage done. All of these parts with their double 10-degree dovetail bevel. And the jaws that made them with the 10-degree, the 10 thousandths shims that go with them. Those are freehand cut. They surprisingly match pretty well. They're all cupped a little bit. So you definitely need to use force holding the jaws down like the quill, because they're definitely springs. So that actually makes them sit pretty nicely. Next up, we want to put a slot an 1/8 inch deep by 6 inches long, 1/8 inch wide. So I've got this 1/8 inch end mill with a 3/8 inch shank. It's a high-speed steel. There's 50 thousandths. Way the hell too fast. So now we're going to drill a hole all the way through to the other side. We're going to put a channel on the other side that's going to direct the gas from over here to here. because the bottom of this is covered. That's how they used to direct the gas. So this is slightly smaller than an 1/8. And then we're going to do an 1/8 inch channel over here, and then we're going to have a feed point there, and we should be done with this part. We made 5 of these. This is sort of a test, so we're going to let them try it and see how they like it. And we're through, no worries. And I might as well pre-drill my feed point so I have something to shoot at. All right, so the slot on back that's going to connect the input hole to the middle of the other hole, the other slot, we're going to only go 50 thousandths deep because there's going to be a flat piece that mates up against this, the bottom of the dovetail. And so gas will just go down here and then go from the middle and push out, which I think should work. We'll just have to see. And we're there. So here's the part slot where the seam is going to go over. Hole in the middle to push gas out evenly both directions. Slot on the other side. This is up against the flat bottom of the dovetail, and the gas will enter here. So I should have drilled this when I had it out, so we'll do that now. I needed to drill that for the tubing. This was a test bend I did on the tubing, did not work out great, kind of flattened out. I had a tubing bender, but it wasn't designed for exactly this size, and so it did not work great, although air still, or in this case argon, will still be able to flow through it. And this is just a test example. So what I'm going to do is I am going to drill this oversized, and I'm going to epoxy this in because unfortunately the diameter of this is 0.164, and if I wanted to make an interference fit, it's not on any size normal drill bit. It's not even on any size metric drill bit. It's like between 4.1 and 4.2 millimeters. If I had a 4.15, that would probably be right. So we're going to drill this part way down, and then we're just going to epoxy this guy in place. And then this guy is going to go in here and be glued in place with epoxy. And I think what I need to do is open the top part up just a little bit more so that there'll be a little pool of epoxy. So what I'm going to do is I'm going to use a end mill, and I'm just going to open this up just a little bit. All right, that's it until we decide on a final design. So epoxy the tubing in, they can put their argon gas in there. You see the hole in the middle, so the gas will flow from the middle out, and you've got the feed tube from one end to the other. So I think this should work out pretty well, but I've got 4 more. This is just a test. I've got the jaws I could make a lot more easily. These are the 2 spacer pieces that go on either side, and I think we're good. Well, my first approach was a spectacular failure. This seemed like a really good idea. This fit right between the plates that hold down the parts on either side, although the epoxy was a little wide and I was going to have to clean that up. However, what I didn't notice is on the camera shot underneath the unit, I couldn't see this, but there was a bar that comes down right above where this dovetail slides in, and guess what? This won't fit past it. So we're going to have to go with an entry from the side, which I was trying to avoid. I mean, originally they wanted me to bore all the way to here, which is like 3 inches. I didn't know if that was going to be even easily approachable. I probably could work it out, but you know, holding parts like this to drill them in a mill is pretty challenging. So I'm probably going to use my angle head and bore in from the side, and that has some problems of its own, but we'll see if we can get that right. So I'm going to, this is my prototype piece, so I'm going to cut this off and I'm going to clean up the top, and then I'm going to bore in from the side, and then I'm going to change the slot to go farther over so that I can pick up this new location, and we'll see if we can make that work. I'm going to have the same tubing without being bent come out the side, and I think that might be a good approach. We will try. Then this piece that mates up with this over here, originally they said just cut some off and we'll leave a gap where the hose comes out, but I think what I'm going to do is I'm going to slot the entire length of this for the hose to lie down, and then a bigger groove all the way in here where the hose can slowly ramp up and fit in the top section. So we're going to do that and see if that works better. First step, remove the old tube and epoxy, and the epoxy, I must say, came off a little bit easier than I would have liked it to. It held all right, but I wish it would have struggled more. That would have given me more confidence in long term. So I took it out, the old tubing out, cleaned out the epoxy out the inside, and then I tapped it for 1032 so I can put a set screw in here. And an interesting side effect of the set screw is that it can also act as a valve to reduce the amount of air pressure argon flow, although I don't think it's really necessary, but I do need to cap this hole so the argon doesn't leak out the top. So we need to drill in the side and just meet up with this hole and we'll be good. I think in future versions I'll probably take the slot on the bottom farther over so I can just take a small drill up into the cavity where the tubing is going to be. But for this one, it's just a prototype. That's why I haven't done anything with these other four, because we want to get it all settled and working before I go and modify them all. If I'd made them all like this, I'd have a lot more work to do, wouldn't I? One of the people there recommended I put one of these fittings in the end. This is a quick release fittings for that tubing, which is really nice. They use 1/8 inch NPT pipe taps, but they're pretty close to the size of this, and I think they're a bit overkill. I think this tubing is close enough to perfect match for the tube for a tight fit but removable. And this is very low pressure, so you know the argon gas is coming at like 4 psi, so it's not going to pop itself off. So I think we're going to still stick with this tubing because I think it makes for a much smaller, low profile fit. I will have to glue it in the end, but I don't think that's bad. Just going to cut the slot. We're going to start in 1/8 inch depth, 1/4 inch wide. Now I'm just going to open up the end of this 3/8 inch wide and go back 1.5 inches or so to give plenty of room for the tubing to drop. Well, there's interesting. So the chips just packed because I wasn't clearing them with air and I wasn't using lubricant. I thought this zircon nitride coated bit would cover that, but then it welded the aluminum chips right on the cutter. That's really impressive, and welded them back onto the aluminum as a whole. That is really amazing. I've never seen that before. Without the lubricant, I should have used the Peck method. I'd heard about chip packing like that, never seen it. Now I have. So I've cleaned off some of the aluminum, but some of it's welded on so good I can't get it off. I'm going to try the sodium hydroxide trick, but I don't know what that's going to do to the carbide underlayment. I'll see if I can find out if that reaction can happen. Really bummer. Might have ruined a perfectly good cutter. All right, so here's the final part. I filed a groove in there at an angle so that the hose could ease up into the channel. And I think we're good to go on the backing piece. Since I don't have enough space under my quill to drill this next part, there are several ways I could approach this. One is I could hang the part off the side of the table down and extend the ram on here out further so that it reaches, and then drill that way. I could also use the 90-degree attachment, which is the approach I'm going to take. I don't know if it's the best one. I think hanging the part off the side might be equally useful, but it's a bit challenging to set up, and I've done it before, and it does work reasonably well. You've got some good rigidity. With this one, the downside is I got to make sure to dial in the the perpendicularity, because I'm trying to drill a 1.5 inch deep hole or something like that. So that can be a bit challenging. Okay, we're lining up the bar, and we've got it within a couple tenths. This is a ground carbide bar I've shown before, 1/2 inch, micro 100. And we should be good to go. It's not moving at all. So we're gonna lock it in place. Got my indicator out here, finding my Y0, going side to side. And now coming up to find my Z. Find the center vertically. So 0.387 there. I'm just double checking now. And 0.387 there, and right on the money. So we can get our middle Z now. And we can go ahead and drill dead center down the side of this part. Now I gotta remember to use the X-axis to plunge, which is really weird, not the quill, of course. This is a pain, never tried it before. Turn my vertical mill into a horizontal mill. And we're through. Right on the money too. Very pleased with the result. Okay, that was it. I think now on the outside portion, I'm going to make it just a little bit wider for epoxy to sit there and hold this in a little more, with a little more strength. Just gonna go in ever so slightly. Just a little pocket for the epoxy to sit in. Here's the test fit. Perfect. So we got to put a set screw in there, and we got to glue this guy in place. Epoxying the part in place. Made a little bridge out of tape just to make sure it didn't accidentally fall in the hole, because it could go in all the way. That would be a problem. And so when this cures, we should be done. Oh, I got to put a set screw in there. As for the end mill and the epilogue, I didn't use sodium hydroxide because the cobalt binder can be dissolved in sodium hydroxide, forming cobalt 2 hydroxide. So I decided I'd rather than risk that, what I did was I took a MAP gas torch, heated this up, and I figured differential heating might break it loose a little bit, and it did. So that with a razor knife, very carefully, yeah, you notice the finger there. Very carefully, you pry under one edge and you can lift the whole piece up out of each flute, which worked out pretty well. So I have salvaged this. There is still some built up aluminum on there that's not coming off, but I think I can still use this for a while. So that saved me some money there. All right, here's the piece all epoxy together with the argon gas tube out the back. The set screws in here. That hole connects to this hole, which goes down this channel. There's flat bottom on the dovetail, which puts the gas up the top in the middle of this and pushes out the sides. And then this piece over here, the tubing is going to go down here, and I've got a slight relief in there so that the tubing can angle up into this tube and stay out of the way. Originally, we're just going to cut off a section, leave a gap, but I didn't like that. And then this piece just goes over here as a filler piece, and that's it. All right, well, we'll let the customer decide how well it works, and if so, we'll make the remaining 4. Thanks for watching. Hope you find it useful. Hope to see you next time.